Okay, welcome back to our weekly webinar for a Certified Fire Protection Specialist course. And our topic for today is a continuation of Module 13, CFPS Special Suppression. So, and this is the part B of our discussion. So let us start. All of the extinguishing agents we discussed last Monday can be used as a portable fire extinguisher for manual firefighting. And before to select an appropriate extinguisher, it is important to understand the physical environment and the extinguisher will be in, as well as the fuel and the hazards present. No? So again, remember, physical environment, the fuel present, and the hazard present. In Section 17 in Chapter 5 of your Fire Protection Handbook, indicates that extinguisher are listed for use on one or more fire classifications. And probably you already have an idea on this because, again, we already have some discussion about this topic last meeting. The Class A is for ordinary combustible. Again, listed for Class A fire include water, loaded stream, aqueous film forming foam, or A4F, film forming fluoroprotein foam, triple FP, multipurpose ammonium phosphate base, and dry chemical and halogenated types. And these are already discussed last meeting. The portable fire extinguisher listed for Class B fire include carbon dioxide, the dry chemical, the foam system AFFF, triple FP, and halogenated agent. For the Class C designation indicates that the portable fire extinguisher will not conduct electricity back to the user. When the extinguisher is discharged onto the fire, the involved energized electrical components. And the agent for classified C use include carbon dioxide, dry chemicals, and halogenated agent, which is non-conductive type of material. For the Class D, combustible metal, it requires a special extinguishing agent do not react with the burning metal. And some of the combustible metal can be extinguished with dry powder, so that's one thing, which can be applied with Class D rated portable fire extinguisher. Other combustible metal may require manually applied agent. For example, sand. No, sand is, especially in Qatar, available everywhere. Also, I've seen this available in many sites, especially near to smoking area. And you can also refer, so just hold on, I have some call. Okay, sorry for interruption. There is some emergency. Anyway, okay. So now we are in the class D, combustible metal. Okay. You can use sand as what we discussed to suppress this kind of fire. And you can also refer to Section 6, Chapter 9 of Fire Protection Handbook for information on combustible metal. So the Class K rated portable fire extinguisher contain wet chemicals. This one we discussed also last meeting, provided for supplemental protection, for commercial and industrial cooking equipment, vegetable fat, animal fat, in conjunction with a fixed wet chemical system. No? So normally we are using here wet chemical system. No? And the relative hazard in the building vary according to its fire load or the amount of combustible it contains, which we already explained earlier. So now let us discuss the types of hazard. So when it comes to portable fire extinguisher, we can refer to NEPA 10, describes three types of hazard: light, ordinary, and extra. Light hazard exists when there are few combustible material or where the combustibility of contents is low. Example include educational, religious offices, or assembly hall. However, some of this occupancy may contain sufficient amount of combustible material to be classified as an ordinary hazard. Ordinary hazards exist where the combustible present are substantial in quantity but ordinary in nature, or where there is small quantity of combustible capable of rapid fire growth. So what are the considered example of ordinary hazard occupancy? As what you can see, mercantile storage, display area, auto showroom, parking garage, and library are also considered ordinary, ordinary hazard. And lastly, the extra hazard exists in area where there are substantial quantities of on-site combustible whose nature or configuration would readily support rapid fire growth and large fire. Warehouse with high pile combustible woodworking area, aircraft servicing area are considered extra hazard location. And these hazards are typically determined by the extinguisher installer, but could also prescribe by code, local authority having jurisdiction, or the standard for the particular occupancy type. This designation used to determine the extinguisher size and required spacing. And some of the example you can be able to see in your fire protection handbook. So let's check our knowledge. Okay, so you can use our chat box to determine the right answer. So let's say for a class A fire, so for class A fire, no, okay, you can use for paper, wood, cloth, and even plastic. Okay, so this is I think very easy. Okay, so another is the okay, so for the class B fire, so we can use on combustible liquid. We discussed it also last meeting. Class C for energized electrical equipment, either class B or A fire. And D for combustible cooking media, media, animal or vegetable fat. Okay? Sorry. Type K is for the cooking. Okay, and metal fire is for class D fire. Okay, so that's make our extinguisher complete, which we discussed already many times. Okay, so this one, typical office. So what kind of hazard, no? Okay, what kind of hazard available in this kind of settings? Okay, so office considered normally you will expect fewer material. Okay, so not ordinary. It's just office is normally has fewer material, no? So it is a light hazard. Okay, correct, Mr. Rahil. And uh, this one, it is a workshop. Okay, but the stock, no, or stocking height is very limited. It's still, I think, considered light hazard. No, okay. This is like a hotel room. Okay, or room, no, still considered for me as or light. I think still considered as still it's a light hazard, guys. No, okay. How about the library? Okay. So now there is a material stock of material, no. So there is a certain height on this, no. So there is a pile of burning material, no. So this is considered ordinary this type, no. Lobby, reception area, okay. Again, fewer materials are available, considered like hazard, okay. And parking, garage, this one is we just mentioned page 126 to 129, no. This is ordinary, okay. Aircraft hangar, we discuss. I normally use foam type system. This one is extra hazard, okay. Mercantile, there are many piles of burning material, so this is considered ordinary, okay. And this one, warehouse with very high pile of, there's a racks and a pile of material. This is extra hazard, okay. Because if you see, the classification normally depends on the volume of the combustible material. Now let us discuss the high-level care and maintenance of your suppression system. Once a fire extinguisher become purchased, no, by your organization, it's become your responsibility to inspect and maintain. And an adequate maintenance consists of monthly inspection, annual servicing, recharging each extinguishing following a discharge, and performing periodic hydrostatic tests as required. Remember, guys, that no personal qualification are required to perform monthly inspection. Monthly inspection required, but not required of no personal qualification. But however, NFPA 10 permits maintenance to be conducted only by trained or certified individual that has access to the parts and tool necessary to perform the work according to manufacturer instruction. For annual maintenance, a tied-on tag and a pressure-sensitive label is used to record the date and inspector's initial. We have some video script here.
Let's hear Barry Chase discuss inspection and testing.
Fire protection systems discussed in this module are only useful if they operate when needed. Along with the design and layout methods, equipment and material selection and installation practices, a program of inspection, testing, and maintenance, usually abbreviated as ITM, is an important aspect of ensuring the quality, functionality, and safety of fire protection systems. Procedures for ITM should always be conducted in accordance with the manufacturer's published instructions, but there are also minimum requirements from relevant NFPA standards for each type of system. While there are specific ITM requirements that pertain to each type of extinguisher or system, there are 6 general requirements that typically apply across the board. The first is a system or equipment acceptance procedure that occurs after installation to make sure the system is installed as intended. Next is a daily, weekly, or monthly owner's inspection that's conducted to ensure that there's no obvious signs of damage or other problems. The third is semi-annual and/or annual inspection, testing, and maintenance procedures that are spelled out by the requirements of the standards or the manufacturer's published instructions. Next is a 5-year hydrostatic test or replacement of all flexible hoses used in the system or on portable extinguishers. The fifth is periodic internal inspections of agent cylinders, and similarly, sixth is periodic hydrostatic tests of pressurized containers. It's generally required that all ITM procedures are performed by a trained, certified technician, except for the owner's inspection, as I talked about a moment ago. Inspection, testing, and maintenance procedures have to be documented, and those records must be retained for a specified period of time based on the NFPA requirements.
Let's hear Barry Chase.
Okay, so let's check in. At what minimum interval should the status of high pressure carbon dioxide cylinder in a fixed system be checked? Okay, according to your Fire Protection Handbook, page 17 to 89, it is every so every 6 months. Okay, for the high pressure cylinder. Next, during a semi-annual inspection of a stored pressure dry chemical extinguishing system, you notice there is an evidence of caking in the dry chemical agent, and what is the necessary action that you need to take. So if it is caking, or if you see here guys, no, they are coming together, they are forming like a solid. From powder is like becoming solid. So probably due to the contamination of some moisture, I think. Okay, that's why there is a caking, or it's actually almost reached its expiration period. So there's no other way but to discard or no longer use this kind of agent. No, okay. So if caking are present, the dry chemical must be discarded and the system recharged according with manufacturer instruction. To improve reliability in a water mist suppression system, how frequently should you drain and refill the stored water cylinder? In the chapter 16, page 161 of your Fire Protection Handbook, similar to carbon dioxide every 6 months. To improve the reliability of nozzle and valves is to drain and refill the stored water cylinder semi-annually or every 6 months or twice a year. Okay. Let us discuss the explosion prevention and protection. And there are 2 standards address the protection. Obviously, for explosion and deflagration, there is NFPA 68, standard on explosion protection by deflagration vent, and NFPA 69 on explosion prevention system. Deflagration, again, we discuss it many times. I think it's not just 10 times we discuss, but again, for the sake of the topic, let us discuss it again. Deflagration is where a combustion reaction front propagate through a premixed fuel-air mixture, velocity, just remember, velocity less than the speed of sound in the unburned mixture. Where the reaction rate exceeds the speed of sound, if you remember, we call it detonation. Okay. So here is an anatomy of explosion. Okay. To the ingredients of explosion, you need two things, no? Confinement and oxygen. Confinement is actually uh, create pressure, and if the pressure exceeds the capacity of the confinement, definitely there will be an explosion. Okay, presence of fuel, dispersion of the fuel, no? How dense it is, no? And ignition, no? Source of ignition. Okay, and according to the theory, no? The development of an explosion is a form of cold compressed gas. And how we define explosion? Okay, it is the bursting or rupture of an enclosure or confinement or a container, for example, due to the development of internal pressure as a result of deflagration. So if you see the development of explosion, there is a cold compressed gas. And if you see there is a pressure wave, okay, and depends on the explosion, you can experience the pressure of explosion even miles away, no? The flame front. Okay, so if you see it's exploding, no? So how we could be able to do that? It is possible to happen in our system, in our piping especially. Anyway, the deflagration suppression is the key in order to prevent this kind of deflagration, okay, and explosion. And deflagration suppression is a special case of fire extinguishment and may be viewed as a competition between a rapidly rising heat release rate from the combustion zone and the rate of agent delivery. Deflagration is a primary concern in an environment where combustible dust and particulates or other flammable vapor may become ignited. And deflagration will be suppressed when the extinguishing agent rendered the unburned fuel air mixture non-combustible and flame has been cooled to the point of total extinguishment. Okay, so to better understand, no, we prepared the video. Let's see how this kind of phenomenon happen.
Deflagration suppression systems are active systems similar to fire protection systems that have components for detection, extinguishment, and control or supervision. Because a deflagration grows much more rapidly than a surface fire, the overall system response time is one of the key design parameters. The principle of operation is that once detection of ignition has occurred, the extinguishing agent is delivered to and distributed within the protected volume more rapidly than the spread of the flame front. Let's watch how deflagration suppression works. No matter where a deflagration starts within the machine, it will be confined to that piece of equipment, as seen here in the animation of grain being processed into cereal. The grain is conveyed through each piece of equipment within the processing system: the dryer, the cyclone, and the dust collector. The parts of the suppression system include pressure detectors, suppressors, isolators, interlocks, and the deflagration vent. As the grain travels through the processing system, sparks or burning embers can form. If they ignite, they will become a deflagration. If ignition starts in the spray dryer, the pressure detectors will sense the pressure wave that precedes the flame front and will initiate the suppression system. Suppressors on the dryer begin spraying sodium bicarbonate, and the isolators activate. Isolation devices help to confine the flame front so it does not spread to other parts of the processing system. The interlocks are triggered to close based upon the activation of extinguishers, which stop the flow of air to prevent flame growth. Sparks may initiate in the dryer, but they may not ignite, and they can build in pressure while still in the dryer. In this case, they continue to pass through the system, and those burning embers ignite within the cyclone unit. The pressure detectors in the cyclone sense the pressure wave building and activate the suppressors and the isolation devices in the ducts, as well as the interlock devices, thus confining the deflagration to the cyclone portion of the grain processing system. Embers that do not ignite in the dryer or cyclone may pass along to the dust collector. When detectors become aware of building pressure within the dust collector, they activate the suppression system, setting off the isolators and interlocks. As the final piece of equipment in the grain processing system, the dust collector is equipped with an additional component known as a deflagration vent. When the pressure detectors sense the pressure increase, the vent will open and eject the flame. This ejected flame is either vented directly to the outside of the building or within a safeguarded zone for venting inside a building.
Okay. So the video,
Deflagration
the this kind of phenomenon. So there's another video.
Deflagration suppression systems are active systems similar to fire protection systems.
No, I think it's okay. So let us continue. So the deflagration suppression system, it might come in the exam, typically consists of deflagration detector. There will be an alarm panel and suppressor containing the extinguishing agent that have you seen mounted on the piping system. No? So they may also have gates, fans, and vent doors. So some sudden pressure, it will be detected. It is a pressure sensitive device and it will actuate your suppressing agent. Okay, so that's very, very simple uh, phenomenon that's happening here to avoid explosion. And to ensure the suppression success, the deflagration must be detected at very early stage when the volume of the burning material is much smaller than the protected enclosure volume. And for this purpose, special pressure detector, rate of pressure rise detector, or optical flame detector are used. Extinguisher are a high rate discharge or HRD type, charged with propelling gas, and normally or usually it's a nitrogen, and extinguishing agent. And there are several types of extinguishing agent. Okay, one, water with or without additive, dry chemical formulation, other extinguishing powder, and halon product. Although no longer manufactured, in some instance, halon 1301 or 1011 may still be used for system meeting critical use with permission from EPA or Environmental Protection Agency, because we know halon agent or suppressing agent cause uh, global warming potential and global warming and ozone depletion potential. Extinguishing mechanism used in this system employ a combination of thermal quenching and chemical inhibition. So let's check in. Which of the following define an explosion? No? So we discussed it earlier. Okay. And, so it's C, Mr. Norman, yeah, Mr. Rahil, Muhammad. It's a bursting of an enclosure or container. And the bursting or rupture of enclosure refer to an explosion due to the development of internal pressure from deflagration more than the strength of the container. And which of these typical deflagration extinguishing agent? No? So select all apply. We just discussed in page 17 in the page earlier pages, but you can also find this in your fire protection handbook chapter 17. So the answer here is A, C, correct, Mr. Muhammad, and D, water, dry chemical, and other extinguishing powder used as a deflagration of extinguishing agent. So you have completed this module. Just to recap, because there is also part A of this, you become familiar with the water-based fire suppression and fire suppression without the use of water. We discussed the property, the extinguishing characteristics, and limitation of your extinguishing agent. We also identified the feature and characteristics of special hazards related to the use of gaseous fire extinguishing agent, and we acquaint with the maintenance and inspection for this special type of suppression system. And finally, we also discuss an explosion prevention and the use of deflagration suppression system. Okay. So far, that's all for this topic. And we have a quiz again. Uh, Let me share with you the link. So this is module 13. Okay, let me share. And you have, I'll give you 15 minutes to answer this. Okay, you can start answering now. Okay, so let us answer your quiz. So by the way, though, we have one colleague who passed the exam. So if he could be able to pass using our resources, so I believe, strongly believe, no, that you will also be able to pass like him. Okay. Now, and actually he promised me to that he will provide those additional answers also for you to benefit as well, no? Okay, so we will give you an updates if I already got further questions from him. Okay, but since uh, you will be benefited from their experience, we are also encourage you to share as well uh, your exam experience with us. Okay, so whatever new questions that you might found that not available in our current resources, we'll appreciate your help, no, to your colleague. Okay, which of the following portable fire extinguisher is listed to address fire in combustible metal? So the answer is D, class D. Which of the following most often used to apply carbon dioxide? Select that all apply, total flooding, and local application. Extinguishing mechanism of dry chemical agent include radiation shield, and which of these? We discussed it in page 17 to 19. Okay. Chain breaking reaction, smothering, and cooling effect. What minimum frequency should the owner of chemical extinguishing system conduct visual check to determine if it is in proper operating condition? Monthly. Multi-purpose chemical agent listed for use on which fire? Classification, class A, B, and C, fire. Design and installation and other requirements for clean agent fire extinguishing system are covered in NFPA 2001, which is clean agent suppression system. Which of these are fire extinguishing agent vaporize readily, leaves no residue, clean agent? At what minimum frequency should routine maintenance and detailed system inspection be performed? We just discussed semi-annually. What minimum interval should the supply status of carbon dioxide high pressure cylinder be inspected? We just discussed also every 6 months. And the process of chemically converting burning cooking oil, grease, or fat into soapy foam that smother the fire. We discussed it last week. Not last week, last meeting, last Monday. This phenomenon, we call it saponification, that is available in the page 68 of your handout or page 17 to last 19 of your fire protection handbook. So that's all for tonight. And next meeting, we will discuss the fire sprinkler installation requirements. So I hope you answered the quizzes. And if not, please submit. Okay? Have a pleasant evening to everyone and see you next week, next Monday. Bye-bye.